Hey everybody, it's Innovision! And lately there's been a lot of buzz in the community about lossless scaling. And that's due to its recent availability in SteamOS. We've been getting a ton of questions about it. In today's video, we'll show you how to get lossless scaling up and running on any device that supports SteamOS. Full disclosure here, I'm not a fan of this technology, and more specifically on AMD devices. I think there's a whole lot of work to be done. To me, it just feels like everyone's making a big deal and a big whoop-de-doo over really not that much. We will discuss and provide scenarios and gameplay footage where lossless scaling does perform quite well. We'll also discuss scenarios where it's not quite ideal. Stick around because you don't want to miss any of it. For those of you who are unfamiliar with it, lossless scaling is a software you can buy on Steam that provides various frame upscaling and frame generation technologies. Up until recently, lossless scaling was only available on Windows, but due to recent developments in the open source community, we have the ability to take the Windows DLL from the purchased app and use a third-party DekiLoader plugin to be able to read the DLL file and implement lossless scaling in SteamOS. The way this works is some very talented developers implemented a Vulkan compatibility layer, and it allows them to inject the approximated frames into the Vulkan surface that's used for rendering the game itself. And there's a whole huge technical discussion about it, but these guys are very talented for being able to kind of reverse engineer and figure out this process. Hats off to them. That's not to say that the lossless scaling plugin isn't brought to you without some drama. Some YouTubers took the lossless scaling plugin and immediately were making videos about it, and what happened was there's a secondary developer that's developing the plugin, and then the folks that actually developed the technology for being able to do the frame injection in the Vulkan surface, people started having support problems and they were flooding the developer of the technology with these support issues when really they should be going to the developer of the plugin. But since then they've kind of worked it all out, and it sounds like it was just a big miscommunication. But in general, that's what happens when people take things and run with it. You need to kind of just step back, analyze the situation a little bit. At the heart of the problem is the fact that it was kind of presented like, hey, here's this thing, it's working, it's awesome, but in reality it's still highly experimental and there's still a lot of work to be done. I'm actually not talking about lossless scaling and its implementation on SteamOS. I'm really talking about AMD's frame generation technology. It's subpar and inferior to nvidia's DLSS. I know you may be thinking, well, an nvidia graphics card's like at least $1,000, sometimes $2,000. Of course it's going to have better frame generating capabilities than a $600 or $700 handheld. Well, but the Legion Go 2 hasn't been released yet, and pretty soon you're going to be paying similar prices for handhelds that you do for a graphics card. So I'm just saying, one of them has a lot better implementation of that kind of technology because it's more mature, it's been around longer. These are the teams that were originally developing these techniques, so they've got like a 10-year lead over everybody else. For the installation that I recorded, I was using my Legion Go S, but I also have it installed on my Legion Go, and this also works on a Steam Deck, and in general it works on any SteamOS device. Are you ready? I'm ready. Let's get started. Alright, so to get the lossless scaling DekiLoader plugin set up, we're going to start by going to desktop mode. So the first thing you want to do, if you've never installed DekiLoader, you're going to open up console under system and then console with a K. You're going to type PASSWD for password. And in my case, I already have a password set, and so it's going to ask me to change the password. If you've never set up the password before, you would just type in your password twice here and it would be set. And this is the administrator password for when you go to install things at the system level. And so I'm not going to continue with this because I already have my password set up, but I'm just showing you in case you need it. The next thing we're going to want to do is download DekiLoader from the web. If you haven't installed Firefox yet, it's going to prompt you to install it from the Flatpak hub at this point. And then we're just going to go to Google. And I'm going to search for DekiLoader. And typically two sites will pop up. One's the GitHub project page. The other one is this deki.xyz. That's the one we want because this is a downloadable installer. So we'll just go here and click download. And it downloaded it to our downloads folder. And so we're just going to double click on it and click execute. And it's going to ask you if you want to continue. And we're going to say yes. And now it's going to ask us for the password you just set. So in my case, I've already installed it before. Normally the topmost option would be install Decky Loader. If you're on SteamOS stable, which most likely you are, you're just going to want to use the stable. If you're using one of the beta or preview branches, you're going to need to use the preview channel, but I recommend staying on Steam Deck stable and using the stable release. So I'm just going to go ahead and update since it's been a while. Okay, so it finished, and the next thing we're going to do is go back to Google and search for lossless scaling Decky plugin. So the first thing that pops up is the Reddit. The very next thing is this XXJSON. So we want this, and we're going to scroll down to download the latest plugin, latest release. So we're going to click this, and then we're going to scroll down to this losslessscaling.zip file. So we're going to download that. All right, and it's done. And so now we can return to gaming mode. Alright, now that we're in gaming mode, we want to actually download the lossless scaling app, even though it's showing that it's not compatible. One thing I want to note is if you do not have the app, you're going to have to purchase it. And this is the Windows version of the app, so you can use it in both SteamOS and in Windows. The important note here, it's $7 if you need to buy it. So I'm going to click install. It's saying, you know, it's not showing that's compatible. That's fine, because we're going to use a Decky Loader plugin to make it compatible. All right, now it's downloaded. So let's go ahead and configure our Decky Loader plugin. So it's not installed at this point. All we have is Decky Loader. And see, these are my other plugins that I already have for Decky Loader, but we're going to want to go to this cog icon, and then we're going to want to enable developer mode down here. So click developer mode. Now if we click on developer over here, it's going to allow us to install a plugin from the zip file, which is the one we just downloaded from the XXJSON GitHub repository. And so we're just going to go over to our downloads folder and then take this losslessscaling.zip, and it's asking if we want to install it. Yes, we do. So it's done installing, and look at that. We've got a cute little ducky icon for lossless scaling, and we can click into it. And now we need to install this LSFG-VK. So this is a lossless scaling for Vulkan compatibility layer. And so it's showing here the green check mark. That means we already have the lossless scaling Windows app installed. We'll get a green check mark once we click this install LSFG-VK. All right, and so there we are. It's installed and it's ready to go. And in order to use this, there's a couple different approaches. One of them is to set environment variables. I like to do it on a game-by-game basis. And so you would actually copy this right here. You would put it in the command that's used to launch the game. So you click on the cog icon there, go to properties. This example is just for Elden Ring. See the launch options for the game? We would just paste that right there. And now we can use lossless scaling with Elden Ring. At the heart of all of these frame generating technologies is something called motion estimation. The most widely used algorithm for estimating motion of objects is a technique called optical flow. And it originates from the 1940s, but in the early 80s, there was a ton of developments in the computer vision community that allowed us to quickly and efficiently compute optical flow. And that optical flow is the motion of objects within a frame of image data over some period of time. It all works on this concept of within a given neighborhood of image data, the motion of that neighborhood isn't going to change very quickly or abruptly in time, and in time is going to be your next frame. And just so you all know, every computer vision scientist has studied optical flow, or at least knows of it. In fact, when I was a grad student, I've implemented the algorithm. Given a frame of image data, if we were to break it up into neighborhoods, any neighborhood surrounding a group of pixels isn't going to change that abruptly within time. And so typically when we're talking about within time, it's the next frame. So from one frame to the next, the amount of motion a small neighborhood of pixels exhibits isn't going to be that much. It's going to be a small amount of motion, and it's going to be a constant amount of motion. All these optical flow techniques work on that premise. While the actual machine learning model that approximates the next frame of image data, these are kind of opaque. It's a black box. We don't necessarily have all the implementation details, but these are vendor specific. This could be your FSR 3 frame gen or the upcoming FSR 4 frame gen, these things that are being developed by AMD, but it could also be your DLSS frame gen developed by nvidia. All of these frame gen technologies take optical flow estimation into account when they're trying to predict the next frame. They're taking a prediction on the motion of the objects within the image along with the image data to predict what the next image will be. Now, one thing that is very exciting to me, at least on the AMD front, is this PSR, the PlayStation Spectral Resolution. So they're working with Sony, and they're starting with the PlayStation 5 Pro. They're implementing their own frame gen and upscaling techniques. And that's exciting to me because I've seen side-by-side comparisons of the PSR upscaling and frame gen compared to NVIDIA's DLSS. NVIDIA still performs a lot better, but it feels like PSR is an improvement over the FSR 3 techniques. And so that's exciting. I think that that's going to allow for some rapid improvements in the AMD space for this technology. But I just want everyone to keep this in mind. What we're doing is we're bogging down our system to create, simulate, and render fake frames in between rendering real frames. And so on resource-constrained devices like handhelds, it's not necessarily better. You might perceive it as being better because it looks better, but you're always going to pay the piper somewhere. Whether it's going to be an input latency or general like aliasing and dropping real frames, you're going to essentially generate jank in the system. So the in-game frame generation runs a lot smoother and has a lot less latency. It's far less latent than using a third-party application like lossless scaling. And this isn't due to, lossless scaling, doing this whole Vulkan dance on SteamOS. This is the beast that we call lossless scaling. It is a third-party application that's trying to inject something into a pipeline that's running in real time. And so the one that comes with the game typically will perform better in terms of raw performance. Visually speaking, it might not perform better. You'll see this when we show you Oblivion Remastered. The in-game FSR 3 frame gen has tons of aliasing, especially if you have your sword out and you're moving around in the environment, you'll see that. And that's an example where lossless scaling looks and performs better. But also, Oblivion Remastered is kind of a slow game. So generating these frames I don't feel the input latency while I'm playing it. But then if you take a game like Elden Ring, I've sunk more than 120 hours into that game. It's a game that requires exact precision in the fight combat animations, and any jitter in that timing, I feel it and it affects me, and I don't like it. Now let's take a side-by-side look at Ratchet and Clank A Rift Apart. On the left-hand side, we're using the in-game FSR 3 frame gen and upscaling. On the right-hand side, we're using the Insomniac Games upscaling with the lossless scaling 2x frame generator. What I want you to take note of, in the top left-hand corner on both of the game screens, we've got the game scope performance counter that's provided by SteamOS, and we've got a graph that's showing the jitter in the frames that are being rendered. So if we see a flat line in general, that means that everything's running smooth. There's not a lot of inconsistency in our frame rendering times. But if you see a lot of fluctuation there and it looks very busy, that means that we're seeing a lot of inconsistencies and jank when we're rendering our frames. And take note of what the graph looks like in lossless scaling mode.
Dark nights when the shadows start creeping, streets whisper, ain't no safe sleeping. Eyes watch from the corners, they scheming. Gotta move quick, can't let them start feeding. Heart pounds, every step I'm misleading. Make calls from the alley, can't be seen. Hide in the black, can't let them intervene. Grip tight, every moan's echo up past deeds. Grit teeth, ain't no time for the weak. Dark nights when the shadows start creeping, streets whisper, ain't no safe sleeping. Eyes watch from the corners, they scheming. Gotta move quick, can't let them start feeding. Heart pounds, every step I'm misleading. Make calls Walls from the alley can't be seen. Hide in the black, can't let them intervene. Grip tight, every moan's echo up past deeds. Grit teeth, ain't no time for the weak.
At this point, we've seen how to install lossless scaling in SteamOS, and we've looked at an example of lossless scaling running on our OG Legion Go. Now I want to take a second to show you how to actually configure the settings within the Decky plugin for lossless scaling, and then look at a few gameplay examples. Before we get started playing Elden Ring with lossless scaling, let's take a quick look at the settings it gives us. So if we go in lossless scaling, this top level toggle, toggling it on will enable it, and then toggling it off will turn it off. But we've also got a 2x, a 3x, and a 4x multiplier. I've noticed a bug in this UI. If I go to, like, let's say 3x and back out of here, sometimes I can't go back down. See, I'm trying to tap it back down. I have to go all the way up to 4x before I can bring it back down. So that's something to be mindful of. This flow scale, the way these algorithms work is they create motion vectors to kind of predict what the behavior is going to be in the image in the next frame. And so I just leave this flow scale at the default. I'm not playing in HDR on my handheld, and I leave this performance mode option ticked. This immediate mode sounds like it's an experimental thing to reduce the input latency. The last thing I want to call out here is anytime you make a change in these settings, you're going to have to exit the game and go back in for it to pick up those changes. So this is not one of these plugins that you could be playing a game, make some change, and the change will immediately go in effect. You have to leave the game entirely and come back in. We're going to take a look at Elden Ring and Oblivion Remastered for our next two examples. One thing I want to call out about Elden Ring, visually speaking, it looks magnificent, but in terms of input latency, I feel a big difference. Oblivion, on the other hand, looks and feels good. So we're taking a look now at Elden Ring without lossless scaling enabled. So we're just going to go in here and see it's turned off. And I use the same settings across both gameplay sessions. We're at full screen, full panel resolution. We're using the low graphics quality preset with the texture and shader quality bumped up to medium. And one thing you'll see is this game does not maintain 60 frames per second, especially when we walk out into the open world in this area. There's a lot of details at a distance, and these details are difficult to draw and keep the frame rate up. You'll see we typically maintain about 40 frames per second, and it's exactly in these situations where the performance is regressing. We dip to 30-ish frames per second. That's where I feel the biggest delta in terms of the input latency. It's still playable when I use lossless scaling, but what I do to make the game run better, usually I'll just run it at a lower resolution. I'll use 1280 by 800 because it's still a 16 by 10 aspect ratio, so the image won't look squished here. And I want to change my settings here. So yeah, these look good. So I just want to make sure that that was set to auto. And you see we're still not quite at, we're not 60 frames per second, but we're able to stay at 45 or more typically. But this feels really smooth here. In fact, if I applied lossless scaling to this resolution, the game would run even better. But the whole point of it for me is I want to get the best picture quality if I'm using it. This game's already playable like this. And in fact, I've done some back of the envelope calculations. I've noticed with lossless scaling enabled, I'm rendering less real frames because I'm spending more time working rendering the fake frames. And so for a game that's very demanding like Black Myth Wukong, my number of real frames per second drops down by like 3 to 5 frames per second because I'm spending time rendering frames that don't matter. They're fake frames. It might give off the facade that the game's running faster, but it's actually not. But I will tell you this, when I play Oblivion, the built-in frame, you have to play Oblivion with frame gen, and Oblivion's a slow game anyway, so it doesn't matter much there. But there's no way around it on these handhelds. You have to use frame gen on Oblivion Remastered, or the game just looks and plays like crap. And so with that said, Lossless scaling makes the game so much better, and I'll show everyone that in a little bit. Alright, so we've got Elden Ring loaded up here, and we've got lossless scaling with the 2x frame multiplier. Normally when I play this game without lossless scaling enabled, I use a lower resolution than the full resolution of the panel here. I've got the low graphics quality preset where I bump texture and shader quality up to medium, but I've got the full resolution of the panel. And so one thing I want to call out here, I've played, I have over 120 hours logged into Elden Ring, so it's a game I've played a lot. I know the controls very well, and any subtle difference in the controls, I'll feel it. And one thing I do notice when I play this game is there's a small amount of input latency when I use any of the frame multipliers, but the 2x is the most playable one for me. And for those of you who are not aware of it, Elden Ring is a fast-paced kind of combat game where the different actions and motions that you take are part of like a fine-tuned, animated battle sequence. And so the timing really matters here. And so I'm going to find some guys to get in a fight with. And it's going to be, it's not really going to be obvious, watching somebody else play the game. This is really more of a player perception, how you feel while playing the game. But I feel a general sense of input latency. Just like when I attack and fight, yeah, I'm getting my butt beat here. It's definitely playable, but it's not how the game normally feels when I don't have lossless scaling enabled. And so that's just something to be cognizant of. Kind of the general rule of thumb I'm using is I will make sure I have at least 30 frames per second performance without lossless scaling enabled before I enable the 2x multiplier. And if I want to use the 3x multiplier, I typically want to make sure my game's running at least 45 frames per second, but to me it feels janky. Alright, here we've got Oblivion Remastered loaded up, and we're staying at slightly below 60 frames per second. I'm running it in full screen mode, but at the 1280 by 800 resolution, and I have to enable frame gen. The unfortunate state is that this game is very demanding. Even on a desktop PC, you really need to enable the frame gen to get the best kind of gameplay and quality of life. And so I'm going to pick the ultra performance mode just to show that we can get the game to run at 60 frames a second or really close to it. And so one thing I want to call out about the frame gen in Oblivion, look, as I move my sword, it's leaving a streak across the screen. You can see it, like, look to the right of the sword. As I move across the screen, it leaves a striation pattern. As we move it from left to right, see there, it was pretty bad. Look, so it's like almost like a shadow copy of the sword there. Now this is an example where lossless scaling actually makes the game so much better. And I don't notice very much input latency, if any at all. Alright, so here we've got Oblivion Remastered loaded with lossless scaling enabled. We've got our 2x multiplier going. We have slightly different settings. We're sticking with the 1280 by 800 resolution just for comparison's sake, but we'll bump it up here in a little bit. But I just want to show we're still using the low graphics quality preset with texture and post-processing bumped up to medium. But more importantly, I've disabled the FSR upscaling and frame gen because those are the things causing the really gross looking artifacts that we would see on the screen. Right now we're in performance mode with the XESS upscaler, but I just want to show you that it's running, around 70 frames per second. We don't see any of those gross artifacts. There's a little very, very minute ones. It might be hard to see it come through on the video here, but let's try to stand with the water in front of us so you can see a little bit of it. You can see it a little bit, right? On the water reflection itself. But, we're not facing water the whole time we're playing the game. With the FSR, frame gen, and upscaling, I would see it always, just, you know, even getting into battles with people. But it feels responsive. It's playing really nice, and I could even bump up the resolution here. Let's go with the full panel resolution. But to help offset that, let's take the ultra performance mode of the XeSS. And so at this point, it's kind of a matter of preference. What do you want more? Do you want, you know, the highest resolution, but slightly worse image quality, or better image quality and a lower resolution? And you can play around with these settings. For giggles, let's try FSR, but without the frame gen. Yeah, we'll take performance and let's turn frame gen off. Alright. Yeah, I still see the artifact caused by the sword. You can kind of see it there, creating like a little ripple. It's not terrible. It's not as bad as it was earlier with the frame gen. But still, it's not that wonderful. One thing that I think might be interesting is to do a deep dive or further technical analysis of lossless scaling versus no scaling and other frame gen technologies. Let me know what you all think. Hit me up in the comment section. If there's a big interest in that, I could put it together. Those type of things do take a long time to do. And so really let me know in the comments, so that way I know you're interested in something like that before I have to put the effort into it. But in today's video, we showed you how to set up lossless scaling. We gave you a couple examples where it runs well. We talked about some examples where it doesn't run so well. Are there any settings that you guys are using that you would recommend? Let me know. I'm happy to try them and continue studying it a little bit more. Me personally, I'm a big fan of the DLSS technology over the AMD ones, but I'm still not, generally speaking, I don't like frame gen. I'm an OG. I started PC gaming on the first couple NVIDIA graphics cards that were ever made. And so for me, I want to know that my graphics card is generating the image data that I'm seeing, but everything's moving towards this frame gen and AI capabilities, and that's just the nature of the computing world. It's constantly changing. Be sure to hit the like button on the video, hit me up in the comment section, make sure you subscribe so you don't miss all the amazing gaming tips, tricks, and mods we've got coming down the pipeline.